Hello guys, welcome to Leetcoding. In this video, we are going to see the Leetcode problem number 1047. Remove all adjacent duplicates in string. Let's get into the problem. The problem statement is, we are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after such duplicate removals have been made. It can be more that the answer is unique. So let's get on to the problem definition. So before solving any problem, we need to define the problem. So problem defining. So the problem statement is will be given input as string does. So we need to remove the string after performing duplicate removals. Duplicate removals. That is, the output will be yes after string yes after duplicate removals. This is the output, this is the input. So what is a duplicate removal? So before that, what will be s consisting of? S consists of lowercase character English alphabets, lowercase, and what will be the string's length? So it can even be empty, right? So no, I have mentioned that string length minimum is 1. So length is minimum will be 1. So yeah, then what is duplicate removal? Duplicate removal is nothing but choosing two adjacent characters which are equal, two adjacent characters that are equal, and removing it. So choose. So this is the duplicate removal. So how can we approach this problem? Is want to approach. So it's nothing but let's take a sample example. So let's have okay. So let's have the test case as A, B, B, A, C, D. So what will be the case? Firstly, we need to find the duplicate removal. So we need to perform all duplicate removals. So initially, we can see that both B's are adjacent and are equal. So we'll remove the two B's and now the string will become AACD, and now we'll remove AA. So the final string will be CD. So this is it. So this is the case here, and final string will be CD. So how can we perform this? We can easily see that when we keep on moving the traversing the given string, if we find the current string is equal to the previous string, we'll remove the current and previous string. Now we'll move on to other next character, and we'll check the previous character. So if the previous character is equal to current character, we'll remove both the characters and we'll move on to next character, which is C. So we'll check for previous character, there is no previous character, so we'll move to D. So we have come to D. So we'll check the previous character, it is not equal, so the answer will be CD. So how can we keep track of previous characters in order? So in order to keep track of previous occurrences, or in this case there are characters, previous occurrences in order of insertion backwards. So in this case we can clearly see that in these cases we are going to use a stack. So stack can be utilized in these cases. So pattern for this case is stack. So how are we going to use the stack? So initially we'll keep on inserting the elements into the stack, and when we reach an element, which when we reach a character, we'll check the top of the stack. If the top of the stack is equal to current character, we'll remove the top character and move on to next character. So I'll give you a walkthrough over an example. So initially we'll be having a stack. So let's take a sample test case. So initially we got A. So we insert A into the stack. Now we'll go to Z. We check for previous. This is the top of the stack, right? So we'll check the previous character. This A, which is not equal to Z. So we'll insert it. We'll move on to next character. We find top of the stack is Z, which is not equal to X. So we'll insert it. So we'll move to next character. And the top of the stack is equal to X. So we'll just pop it and continue. We have reached Z, so we'll check the top of the stack. Top of the stack has character Z, so we'll remove it and we'll move to Y. So top of the stack is A, so we'll just insert Y. So after this we have completed iterating over every character in the string. So we'll form the string using the inserted character. So inserted character in the stack, so we'll form it by popping. So initially it will be they will form the string using a string builder. Initially string builder will be empty, so we'll pop y and we'll pop a. Each time we'll append to first character, so final string will be ay, which is the required answer. So the time complexity of the approach is go of n, and the space complexity is go of n. So why we are having time complexity as n? Because we iterate over each character at least one time, and at least and maximum will traverse over them only one time, yeah, for n time. Then the space complexity is big of n, because at most, at the worst case, we'll be having the stack space up to number of elements in number of characters in the string. So this is all about the space complexity. So we can also have another approach. So in this we are going to use a two pointer approach. So without stack, can we implement this logic? So yeah, we can implement this. So how can we implement this logic without stack? So it's simple, just by using a two pointer. So consider a z x z y. In Java, the string are immutable, so we cannot change the value in the string. So we'll for initially create a character array. So we build a character array. So we have the top value as -1 initially. So we'll keep this top as -1. We'll iterate over the characters. So when we reach the first character, we'll check the top value. If the top value is -1, we'll just increment the top by 1 and add the current character to the value of the current index. So we'll replace a by a and we'll move on to next character. We'll check the top value. Now we have reached index 1. We'll check the top value. the top value is 0, so we'll check the 0th index. So 0th index has contains character A, so A is not equal to Z, so we'll continue. Before continuing, we'll increment the top value and store the current character to the top value. So top value I incremented by 1, which will be 1, and that will be updated in the character, the position of top, which is Z. So we move on to next character. Now we'll check the top value. Top value is the value at index of top is Z. So Z is not equal to X. So we'll increment the top and replace with current character. Yeah, so we'll move on to next character. Now we'll check the top character. So top character, the index at top is X, which is equal to current character, so we'll just decrement the top, so top will be 1. So we'll move on to next character. So we'll check the top character at top. So the character top is first index is Z, which is equal to fourth index, that is Z. So we'll just decrement the top. Now the top will be 0. We'll move on to next character. So I'll check the character at top. So the character at top is not equal to current character, that is A is not equal to Y. So we'll increment the top and update the value current character. So we'll have ended traversing the each character of this thing. So finally we'll form a string by adding characters from 0 index 0 to top value. So from top to from 0 to top, we'll add up all the values to the string builder. So we'll open the character from indexes 0 to top to string builder and return it. So the time complexity is same as before, but in this case we haven't used any stack, so no stack involved here. So that's it, and the space complexity and time complexity are same as previous example. So let's get on to the coding section. There you will be getting a clear idea of both the approaches. So we're going to implement both the approaches. Yeah, firstly we'll use the first approach, which is stack. So we'll create a stack of characters. We'll call this as previous characters new stack. So write it over each character. So if stack is empty or previous characters, that is the previous character is not equal to current character, so we'll call this a current character as ch. So ch will be a stored character at, in this case we insert current character, or else we'll pop the top value. So finally we'll be creating a string builder, and while stack is not empty, we'll insert previous character to the first index, zeroth index, and finally we return the string representation of the string builder. So let's check this out. Sorry, we have to use pop. That's working fine. Let's submit it up. Yeah, accepted. And we'll go to the next approach, which is two pointers. So in this, initially we'll have a top value as -1 and we'll be iterating over. So before that we'll have this as a help. We'll be iterating over each character. So we need to convert the given string into character array. So we'll call this as array arr start to char array. This function will return the character array of the representation of the string s. We'll store this in the store this character array with the reference arr and we'll be iterating over each characters and we'll get the current character which is start character at 5 and if top is equal to -1 or character at top is not equal to current character, we'll just increment the top and assign the current character to the top value, current top, or else we'll just decrement the top. Finally, we'll be creating a string builder and we'll iterate from 0 to top and append the character at 5 and finally return the string representation of the string builder. So let's check this out. It's working fine. Let's submit it up. Yeah, it's accepted and it is pretty faster than the previous approach where we use this stack. So that's all about this problem. Thanks for watching this video. Have a great time.